Hello friends, welcome to your only channel Times of Coding. Today in Scala Express series, we will learn class ladder. This session will help you to understand class ladder and default super and subclasses of Scala. In previous session, we have covered composition, inheritance relation, how to define abstract classes, and how to define factory objects. In this session, we will learn about Scala class ladder, few people calls class hierarchy also, and we will see what are the default parent and the bottommost classes in Scala. Any is the parent class of all classes implicitly, and null and nothing are the subclasses, and they are by default. So any is the parent of any class in Scala by default, and null and nothing are the bottommost classes, which will be subclasses any class whatever we have defined. That means all the methods of any class also will be available for our custom created classes, and the same methods we can invoke in any object. The immediate subclasses of any are any val, here, and any ref. Same you will notice in this diagram also. So you see Scala.any is the supermost class, and any val and any ref is the immediate subclasses of any reference. So here you see all the value types, because it is a any val, so all the value types classes, subclasses of any val, like double, float, long int, short, byte, char, boolean, and unit. Unit is a void. So in Java we call as void, in Scala we call as unit. And then we have got AnyRef. So AnyRef is equivalent to object class of Java if you wanted to compare. So here we are having all the other Java classes. This we are having some collections also, list, sequence, iterable, string, which we have already seen. And that's how Scala class hierarchy so far. Now coming to null, all the reference type, because a value cannot be null, all the reference type will be having a subclass called null, and nothing will be the bottommost class, which will be bottommost by default. So that means these values we can assign in all the classes, whichever pointed from these arrows. So here I am giving you some methods which is coming from the any class. Since any is the parent class of all, so these functions will be available to all the objects. We do have equality check, and then we have got hash hash, then we have got another equality check as instance of, equals, hash code is instance of, and toString method. If you see, few methods are same as Java object as well. Moving on to AnyVal. AnyVal is the root class of all the types in Scala that we have seen in earlier diagram also. Basically, it is having 9 types of values classes. So first it is having byte, short, char, int, long, float, double, boolean, and unit. And we can have few method invocation also on these value types of classes object. So now I'm defining one 44. 44 is an int type in Scala. So I will convert this int value to a string value, and that's how we will be converting a string is equal to 44, even though it is an int value. And here we will check is instance of. So that means 44 is instance of int type or not. So this will give us true or false on basis of the class which we have given here, just to check the type of object. So 44 is the value which is int type, and we are getting true as expected. Now we will see the hash code of 44. So we are having 44 as it is. And then we will see 44 equals to 44, and this also we should get true as we expected. And all these methods are coming from any class here. Alright, so all arithmetic and boolean operations will be supported by these value classes as well. It inherits all method from any class as we have seen above. Likewise, if you see, AnyRef is the by default parent class, or we can call it base class for all the reference classes in Scala. So you can treat object class of Java as AnyRef class of Scala. But you will notice one difference here. When you do the equality check, in Java basically one is reference based and one is value based. Where in Scala we just have the value based check, and we mostly focus on the literals values. So now we will have a look. So here we are defining one variable called string type, and we are assigning value called TOC. And these two variables are different. When we do the equals, it should get us true, because here in Scala first we check the null, and then we check the equality. So these two variables are not null, so it matches the condition of equals, and these two variables are having equal value, so we will get true. Same we can achieve through is equal to operator as well, and we will get the same. Now what if we need to do the equality check on basis of reference? So for reference equality check, we are having EQ and NE. EQ basically for equals and NE for not equals. And here we are defining two reference type of object. I'm creating one object of this class and then I'm giving a value in argument as TOC. And then we are defining BX, and likewise we are having equality check. So here you will see the reference based equality check. In fact, value is same, but since reference is different, this is giving us false. And then here also value is same, and this is not equal on basis of reference, so it should give us true. So next we have seen null and nothing. Null is basically helpful in cases of reference type because we cannot assign null in any value type of classes. And if we try also like in this statement I'm trying, you will get compile time error called an expression of type null is ineligible for implicit conversion. Since nothing is the bottommost subtype of every class, so there is no exist of this value type. You may be wondering why do we have this value. So I'll tell you one example here. In case of abnormal termination, let's say if any exception is arising from our code, in that case, this will be helpful type for our value as well as our reference type of objects. So here what I'm doing is I'm defining one method called throw error. In this throw error, I'm simply passing the debug message, and whatever debug message we will get, we will throw a new exception with that debug message. So that's the whole thing I'm doing. Since that's how an abnormal execution happens, that's why we are keeping it nothing. So when we throw an exception and we terminate our program, we actually don't return any value. So in that case, this nothing will be in effect. So in theory, we have discussed today content. Now it's time to do some practice. So our IntelliJ is started. Now we will create one package as class ladder, and in that package we will create one Scala worksheet today, and we will name it as examples. The very first example which we have seen is about converting an int value to a string value. Now we will execute. After execution, we are getting 44, and this type of variable is string. Now if you write just 44 here, you will get int type. Okay, so after this example, we have seen as instance of where we are checking whether 44 is int type or not. In fact, this is very obvious now. And then we are printing hash code, and then we are having equality check with equals method. As expected, for equals we are getting true, 44 as hash code, base instance of true, and a string value as 44. Next example we have seen where we have compared to string value type. So here I'm defining A, and then we are defining B here. And in order to do equality check, I will write it A, and we can write A equals, and now I will run it. So here also we are getting true, and here also we are getting true, even though these two are different variables, but in a Scala we don't have preferences to the reference. By default it matches with the value. So now how we should do the reference check we will see. For this we need to define a string as class object. So here I'm defining AX and BX for a string class object, and in that class object I'm keeping TOC as argument value. And then with this method helps, we will do the equality and not equality checks. So now it's time to run. Before I'll clean up the output of previous example now, and then we will run. Okay, so as expected, here we were expecting false because references of these two variables are different. And then true because these are not equal. Now after this example, we have seen if we can assign some null value in the values type variable. So I'll run it, and we are having compile time error here as we have discussed earlier. So you may be thinking then where to use null. So in order to use null, you can do like this. Variable, let's say AB, and this is having a type of a string, and in this string type you can keep null. So I'll just comment this statement and we will execute this now. So as a string, because a string is a class type which is a subclass of any ref, we can assign null here. Now we will see the use case of nothing. So I'll simply delete this code, and for nothing I'm keeping one method here as throw error, and then we are having debug message as a parameter of a string type, and this will write nothing. Why? Because we are throwing just one exception out of this statement. So in order to show you example, we need to make this as object. So after defining this function, we will run it. Okay, so our object has been defined now, and now it's time to call this function. So I'll call it, and here I'll keep it TOC nothing example as debug message. So if you notice, here we are throwing an exception because we have kept exception here, and in that exception we are passing TOC nothing example, so it is coming as it is. Now with this example we have completed today's content. I hope you liked today's session. You can like, subscribe, comment and share with your friends and colleagues to share this knowledge. Thank you. Have a good day.